Welcome to EnfinityCast. Today we're trading the cosmos for the hydrosphere, diving deep into our planet's last true frontier, the ocean. It's a staggering thought that we have more detailed maps of Mars than we do of our own ocean floor. Here to help us navigate these uncharted waters is my co-host and fellow explorer of the unknown, Orin Strath. Orin, welcome.
Thanks, Elion. It's a fascinating and, frankly, humbling topic. We think we know our planet, but over 80% of the ocean remains completely unexplored. It's the Earth's own alien world.
Exactly. And in the small fractions we have explored, the discoveries are mind-bending. What's one of the more recent findings that has really captured your attention?
I'm consistently amazed by the life around hydrothermal vents. Just recently, a team using an ROV, a remotely operated vehicle, in the Pacific discovered a new species of hairy snail. Its shell is covered in these iron sulfide scales, almost like a coat of armor, and it thrives in water that's superheated and toxic to almost anything else. It lives off chemical energy, not sunlight. It's called chemosynthesis.
That's incredible. So, from an analytical standpoint, how does an ecosystem like that even begin to function? It completely rewrites the basic rules of biology we learn in school, which are all based on a photosynthetic food chain.
It does. At the base of this food web are microbes that metabolize chemicals like hydrogen sulfide erupting from the vents. The snails, crabs, and tube worms then either feed on these microbes or have a symbiotic relationship with them. It's a self-contained world running on geothermal energy from the planet's core, completely independent of the sun. A stark reminder that life is incredibly tenacious.
And it highlights the importance of studying these as whole ecosystems, not just isolated curiosities. But that must be a monumental challenge. How do scientists observe these delicate environments without inadvertently destroying them?
Very carefully. The technology is key. Modern ROVs are equipped with high-definition cameras, sensitive robotic arms for taking samples, and a whole suite of sensors to measure temperature, pressure, and chemistry without being too invasive. The goal is to be a silent observer to see how this world operates when we're not interfering.
Which brings us to a more sobering point. Even in these remote, seemingly untouchable depths, the impact of human activity on the surface is being felt. What are the primary threats these deep-sea frontiers are facing from climate change?
Unfortunately, no part of the ocean is immune. The two biggest culprits are ocean warming and acidification. As the ocean absorbs more CO2 from the atmosphere, its pH level drops, becoming more acidic. This is catastrophic for organisms that build shells or skeletons out of calcium carbonate, from the hairy snail we just talked about to deep-sea corals that form vast, ancient habitats.
And I imagine the cascading effects are devastating. If those foundational shell-building species are compromised, the entire food web that depends on them is at risk of collapse.
Precisely. It's a chain reaction. We're discovering these incredible, unique ecosystems at the very same moment they're facing an existential threat from a problem originating thousands of meters above them. The urgency to explore and understand is matched only by the urgency to protect.
A powerful and critical reminder. We're in a race to catalog life before it vanishes. Orin, thank you for shedding some light on this deep, dark, and beautiful part of our world.
My pleasure, Elion. There's always more to explore.
That's all the time we have for today on EnfinityCast. Join us next time as we continue to probe the frontiers of knowledge.